So in this video we're going to be looking at the relationship between launch angle, launch height, initial velocity on the time of flight of a projectile. So I'll go one dot point by one dot point on the following slides. So the first thing you need to be able to do is explain qualitatively that the maximum range of a projectile, the maximum range occurs at a launch angle of 45 degrees for projectiles that land at the same height from which they were launched. So 45 degrees results in the maximum angle. So if we launch it from 60 degrees, the projectile goes so far. If we launch it at 45 degrees, it goes further. And if we launch it at, I'll do in between, we'll do 50 as well. 50, not quite as far, almost, but 45 degrees just wins. And we'll check 40 just to make sure it's not further. So 45 degree angle, so when a projectile is launched at the same height as which it lands, the 45 degree angle results in the maximum range of projectile. Now, the reason being is that the initial horizontal and vertical components of velocity are equal to one another at a 45 degree angle, and remember the time of flight, the horizontal range of a projectile is based on its horizontal component of velocity and its time of flight, and its time of flight is governed by its vertical component of velocity. So the second thing you need to be able to do is you need to be able to describe the relationship between launch angles that result in the exact same range. So looking at this data, you'll notice that an angle of 30 degrees and an angle of 60 degrees results in the same horizontal range. Same with 40 and 50. So the relationship is that two launch angles that sum up to or add up to 90 degrees result in the exact same horizontal range. And I'll show you in the simulation. So 40 degrees and 50 degrees both result in the exact same horizontal range. Same with, I can't go down to 30, 25 and 65 plus 25 sums up to 90. So they're going to go the exact same horizontal distance. So that's the second thing you need to know from this video. Two launch angles that sum up to 90 degrees result in the exact same horizontal range. And here's just a diagram. So from here you can see a launch angle of 70 and 20 result in the exact same horizontal range. 60 degrees and 30 degrees result in the same horizontal range. And then 50 and 40, etc. Now, the other things you need to be able to do are the following. So the next thing you need to be able to do is you need to be able to describe and explain the effect of launch height on the time of flight and the maximum range of a projectile. So in competitive sports such as javelin, discus, shot put, anything that you're launching a ball or object, then the projectile is going to be launched from some height above the ground. Now, assuming we keep the velocity and launch angle constant, well, we want to be able to describe the effect that launch height has. So I'm going to keep the angle constant, so we'll just make it 45 degrees, the launch speed constant at a velocity of 10 meters per second, and we're going to increase the height. So 1 meters, launch from above the ground, and then we're going to increase the height. So just pause and think, what do you think is going to happen to the horizontal range of the projectile? Yep, it's going to increase. As we increase the launch height of projectile, the horizontal range is going to increase. The reason being is that as we increase the height of the projectile, we're increasing its time of fall. And as we know, the horizontal range is equal to the horizontal component of velocity multiplied by its time of flight. So increasing launch height will increase the distance the projectile falls, hence the time of flight, and then hence the maximum range of the projectile. Second thing you need to be able to describe and explain is the effect of the launch speed on the time of flight and the range of the projectile. So Similarly, we're going to keep the launch height and launch angle the same this time, and we're going to increase the initial speed. So again, make a prediction. What do you think is going to happen as we increase the initial speed, the initial velocity of the projectile? Increase it a couple meters per second, goes much further. As we increase the initial speed, it's going to go further and further and further and further. The reason being should be obvious. So as we increase the initial velocity of the projectile, we're increasing its initial horizontal component and its initial vertical component. And the vertical component, as we increase the vertical component, we're going to increase its time of flight to its peak and then hence to the ground. So increasing time of flight. And the horizontal component, well, we're increasing that, and then we know that the horizontal range is equal to the product of the horizontal component of velocity, which is increasing, multiplied by its time of flight, which is increasing because we increase the vertical component. And I've just explained that on that slide. Vertical component of velocity is increased, hence the time of flight, and then also the horizontal component is increased, and therefore both of these factors lead to an increased range. And finally, describe and explain the effect of launch angle on the time of flight and the maximum range of a projectile. So this one sometimes isn't intuitively clear. So if we keep the launch height of 5 meters and we decrease the speed again, so 45 degrees, well, that is what resulted in max range at on the floor. So when the launch height and the landing height were the same, but now we're increasing the launch height. So 45 degrees still goes quite far, but well, 5 degrees, we'll change the angle. So we'll change it, we'll try 35. So 35 degrees now goes further. Now you don't exactly need to know, so 30 degrees, not quite as far. So 35 degrees 1. 37, about the same. So it wasn't 45 degrees though, it was about 37 degrees was the maximum range. Now, the reason being is that as we increase the height of the projectile, the launch angle decreased because a small launch angle will result in a larger horizontal component of velocity. Now, just having the projectile high in the air, well, that's increasing our time of flight. And remember, the horizontal range is the horizontal component of velocity multiplied by its time of flight. So it actually, as we increase the height of the projectile, it actually is better for optimal range to decrease the angle because then we have a larger horizontal component of velocity. And the relationship, well, if we make it even higher, just having it higher in the air, we're going to have a longer time of flight. So we can actually, we'll try 38 degrees, but we can actually decrease the launch angle even further. And it results in a longer horizontal range. So, as the launch height increases, the launch angle required changes. It actually decreases. So a smaller launch angle results in a larger component of horizontal velocity when the projectile reaches its original launch height, and therefore its range is increased as it has more time to fall at this faster horizontal velocity. And the higher the launch height, the smaller the angle required to achieve that maximum range. So I want you to have got these exercises in the textbook. However, I might change these slightly, so check the Google Doc for which ones to do. Thank you.